Hello everyone, and welcome to Routing 101. In this class, we will be learning how a router forwards a packet based on its IP address. The first thing we're going to look at is...
Is this Routing 101? Sorry I'm late.
It's fine, we just started. Just take a seat. Now, as I was saying, in this class you're going to learn how to be a good router. The first thing I'm going to show you is how to use and interpret a routing table. Let me pull up an example. So as you can see here, we have a very simplified routing table. There's a lot of columns involved, and the most important ones are the first two, the network/subnet and the mask. The network column simply indicates where the next hop is from your router.
Wait, I'm not very athletic though. Should I practice my jumping jacks?
No, that won't be necessary. Hopping merely refers to the next step along the path. Think of it this way. If you consider a packet like a letter, the first step, or hop, is to put the letter in your mailbox. Then, when the mailman picks up the letter, that can be considered another hop.
So what you're saying is that hopping is just the route that the packet is taking.
Exactly. The next, and probably most important column in the routing table, is the subnet mask column. The subnet mask is what you'll be using to apply to your destination IP address to determine where you're going to be sending your packet. Now, there is a lot of logic and complexity with subnet masks, and that can be covered in another class. We're just going to cover the basic. First, you need to know that an IP address is broken up into 4 different bytes separated by a decimal place. For each byte in the subnet mask that is non-zero, that value is going to stay the same in the destination IP address. And for every byte that is a 0 in the subnet mask, that corresponding byte will be a 0 in the destination IP address.
What does that mean?
It's easier to explain with an example. Let's say we have an IP address of 128.171.16.42, and then we have a subnet mask of 255.255.0.0. Because the 2 first bytes of the subnet mask are non-zero bytes, we are going to keep the same numbers for the first 2 bytes of the destination address. However, since the last 2 bytes of the subnet mask are zeros, we are going to turn the last 2 bytes of the destination address to zeros. The result that we have is the final destination address of 128.171.0.0. We then take this value and compare it to the values in the first column or the network column, and we look for matches. This process will be continued for every row in the routing table, and we will keep track of every time there is a match.
Then what?
Then we use the other column headings to determine where to send the packet. If there is only one match, then we send the packet to the router through the interface as indicated by the values in the matching row. If there are multiple matches, then we compare the lengths of the matches. And by that I mean the number of bytes that are non-zero. So, here we have 3 different destination IP addresses. The top one is considered the longest because it has 3 bytes that are non-zero. The middle one is the second longest because it has 2. And the final IP address is the shortest because it only has 1 byte that is a non-zero.
Wait, what if there are matches of the same length?
In that case, we would look at the metric value of each match. The metric is some sort of measurement of the routing table. It can either be the number of hops involved or the cost. In our example, our metric is measuring the cost, so we would pick the match with the lowest value.
But what do we do if there aren't any matches?
In the event that there are no matches, each routing table has what's known as a default destination address. With this row, all of the values for this network and mask are all zeros. That way, no matter what the incoming IP address is, it will always match with this row, and then will be sent to the next hop router as indicated by this row.
Wow, that seems like a lot to remember.
It is a lot to remember, and that's why it's important to review. Now we're going to take a look at a real-world example. By going into your command prompt and typing route print and hitting enter, you can see the routing table for your personal computer. We're going to focus on the IPv4 routing table as it's the most simple case. Now, can one of you tell me what you would do if I gave you the IP address 127.0.0.1?
The first thing to do is apply the subnet mask of each row to the address you gave and see if it matches the network destination of that row. With the IP address 127.0.0.1, there are only 2 matches in this table. Applying the subnet mask in the second row yields an address of 127.0.0.0, which is the first match. The second match comes from applying the subnet mask in the third row, giving an IP address of 127.0.0.1. Since there are two matches, we have to first look for the longest one. This happens to be the match in the third row. Therefore, the packet with the incoming IP address of 127.0.0.1 will be sent through interface 127.0.0.1 according to the table.
That's correct. Well done. I'm glad you guys picked this up so easily. Well guys, that is the end of our class today on the basics of routing. I'm glad you learned so much, and I thank you for coming to Professor Chinwe Chow's School of Routing, and I'll see you next time.